As we know from the second law of thermodynamics, if a process is to occur spontaneously, it must be accompanied by an increase in the total entropy, which is the sum of the entropy of the system and the entropy of the surroundings. For a chemical reaction occurring at constant pressure, the enthalpy change is the heat that is reversibly transferred between the system and the surroundings. So we can calculate the entropy change of the surroundings from the negative of the enthalpy change of the system divided by the temperature. Therefore, a reaction will occur spontaneously if the entropy change of the system is greater than the enthalpy change of the system divided by the temperature. If the reaction has a negative enthalpy change and a positive entropy change, the reaction will always be spontaneous, since a negative number is always less than a positive number. In such a case, the reaction is increasing the entropy of both the system and the surroundings. In contrast, if the reaction has a positive enthalpy change and a negative entropy change, the reaction will never be spontaneous, since a positive number is never less than a negative number. In this case, the reaction is decreasing the entropy of both the system and the surroundings. But what if the enthalpy and entropy changes have the same sign? Well, notice that this term depends on temperature, while this term does not depend on the temperature. Therefore, if these terms have the same sign, whether or not this inequality is true depends on the temperature. If both terms are positive, then this term will decrease with increasing temperature, and so the reaction will be non-spontaneous at low temperature, but spontaneous at high temperature. In other words, at high temperature, the entropy decrease of the surroundings will be less than the entropy increase of the system, giving a positive overall entropy change. If both terms are negative, then this term will increase with increasing temperature, and so the reaction will be spontaneous at low temperature and non-spontaneous at high temperature. In other words, at low temperature, the entropy increase of the surroundings will be greater than the entropy decrease of the system, once again giving us a positive overall entropy change.